In lesson 5.5, we're going to figure out if you know two lengths of a triangle, how to find what that third side length could be. So in our first example, we're going to look at, in this triangle shown here, what relationship we notice between the largest angle and the longest side. So I see my largest angle is 120 degrees and my longest side is 16. So I can see there that the largest angle is across from the longest side. So the largest angle is across from the longest side. Alright, and now let's look at if we can see a relationship between the smallest angle and the shortest side. So I notice my smallest angle is 25 degrees, the shortest side is 8. And again, I can see that it's across from the shortest side. So the smallest angle is across from the shortest side. Alright, and that actually brings us to our first two theorems. It turns out that if one side of a triangle is longer than another side, then the angle opposite the longer side is greater than or larger than the angle opposite the shorter side. On the flip side, if you know one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side across from the smaller angle. And that's really what we saw in this picture up above. So we're going to use those two theorems to do these two examples down below. In example 1, we're told that this triangle WIS has side lengths where WI is 22, WS is 17, and SI is 19. Well, if we're asked to list the angles from smallest to largest, first we're going to list the sides from smallest to largest. So my smallest side is WS, my next biggest side is SI, and my largest side is WI. So just like in that very first triangle we looked at, I can see that WS, the shortest side, is across from angle I, so that has to be the smallest angle measure. SI is the next biggest side, so that's across from W, so angle W is in the middle, and then 22 is across from angle S, so angle S has to be the biggest angle. So this right here is the angles from the smallest to the largest. Now we're going to reverse that process in example 2. This here is 90 degrees, and I have 37 degrees, and here if we take 180 minus 90 minus 37, that's going to leave us with 53 degrees. So now I know these three angle measures. So first thing, if I'm going to list the sides in order from longest to shortest, first I need to list my angles from largest to smallest. I can see my largest angle is 90 degrees, that's angle O. Next, angle C is 53 degrees, and angle N is 37 degrees. So now I have to see what side is across from those angles. So across from angle O, my biggest side is going to be side CN. My next biggest angle was angle C, and across from that is side ON. And then my smallest angle is angle N, and across from that is CO. So these are my three side lengths from longest CN to shortest CO. Alright, we're going to switch gears a little bit here in this next set of examples. So for the triangles shown below, we're going to add the two shorter sides together. In example 3, 10 and 7, the two shorter sides add up to 17. In example 4, 3 and 2 add up to 5. And in example 5, the two shorter sides, 5 and 12, add up to 17. Now we're asked to find a relationship between those numbers and the longest side. So how does 17 relate to 12? How does 5 relate to 4? And how does 17 relate to 13? And I noticed that those sums are all larger than the longest side. So the two shorter sides added up has to be larger than the longest side. And that's actually true for any two sides. If you add up any two sides of a triangle, they have to be greater than the third side in order for you to be able to create that triangle. So if we would, for example, look at a triangle that had side lengths of 2 and 1, this side length would have to be bigger than 3, so it could be 4, but it could not be something like 2, because then you wouldn't be able to connect and make a triangle. Alright, so let's look at some examples using that idea. First of all, in number 7, can you make a triangle with side lengths of 11 inches, 17 inches, and 5 inches? So if we take the shorter two sides and add them together, we get 16 inches. And unfortunately, that is not greater than the longest side. So by that last theorem, theorem 5.12, the smaller two sides have to be greater than the third side. And in this case, it's not, so no, it's not possible. Okay? Now in 8, it's kind of the same idea, but we're given two side lengths and we're asked to describe the possible length of the third side of a triangle. So here's how you can do this. Add the two side lengths together and subtract the smaller side length from the larger. This tells you that the third side could be anything between 2 centimeters and 22 centimeters. Now be careful, because when you use this idea, you have to make sure that your units agree. So in part B, notice we have 2 feet. Well, we need to change that into inches. This is the same as 24 inches. Now you can use that same idea. So add the two lengths and subtract the smaller from the larger. And if we do that, here this tells us that the third side could be anything between 8 inches and 56 inches. All right. In our last example, suppose that you were given a 17-inch piece of wire. You need to bend the wire to form a triangle with whole number side lengths. In part A, we're going to sketch 4 possible triangles. So I'm just going to make a rough sketch of 4 triangles, then we're going to put some numbers that will work. Okay, so let's just pick 2 and 7. That means my third side has to be less than 9 because those two add up to 9. So this is 2 plus 7 is 9, and then this would have to be 8 to make 17 inches. Okay, let's try that again. Pick 2 numbers, say 5 and 4. Again, those add up to 9. So to get to 17, I'm going to have to add 8. Okay, let's pick something that doesn't add up to 9. Suppose we have 4 and 6. So that adds up to 10. So my last side has to be 7. And lastly, I'm going to use 6 and 3. And those two add up to 9. So my third side would again be 8. Okay. Now, a couple of things that wouldn't work in Part B, we're asked to list two combinations that will not produce triangles. So if I have two side lengths of 1 and 1, and then a third side of 15, well, if you look at your shorter two sides, 1 plus 1 is only 2. And 2 is not greater than 15, so that will not work. Okay, let's try something similar. What if we have two sides of 2 and 2? Well, that adds up to 4, so the third side would have to be 13. Well, again, if you add your shorter two sides, 2 plus 2 is only 4. 4 is not greater than the third side of 13. So that also does not work.